NASA has sent rovers to Mars for more than 20 years. They have mapped its surface, drilled its soil, scanned its skies. Yet there is one thing about Mars they consistently avoid explaining. Not because they don't know, but because answering it would change everything we think we know about the planet, and possibly ourselves. Strange formations that don't behave like geology, atmospheric data that doesn't fit official models, and discoveries quietly labeled as anomalies, then never mentioned again. Tonight, we're not talking about aliens or science fiction. We're talking about real Mars data, real missions, and real questions NASA never answers directly. Stay till the end, because once you see this, Mars will never look like a dead planet again. Mars, a planet our eyes have studied for decades, yet one question remains unanswered. One question NASA has danced around quietly in scientific papers, in cautious press releases, but never in plain language. If Mars was always dead, then why does it show signs of striving for life? Rivers that once flowed like veins across the surface, valleys carved with precision, minerals that could only form in liquid water. All signs of a planet that once fought to survive. Rovers like Curiosity and Perseverance send back gigabytes of images, chemical readings, atmospheric scans. Every mission is a triumph of human ingenuity. And yet, the data teases more than it tells. Formations appear, patterns emerge, anomalies that don't fit our models. Seasonal methane spikes, briny streaks, magnetic remnants in unexpected locations. Facts that are carefully cataloged and then quietly ignored in public narratives. Dirt samples analyzed, craters dated, ice layers measured. And still, no simple answer. Each discovery raises more questions than it solves, and the most uncomfortable ones are left hanging. Why does a planet that should have died billions of years ago look as if it had a purpose? A story that NASA can't or won't explain. Something about Mars makes scientists pause. Tonight, we're diving into these anomalies, not the headlines you've seen, not the glossy videos from public channels. We're talking raw data, strange formations, and phenomena that challenge everything we think we know about the red planet. And by the end, Mars will never look like a dead, lifeless world again. Billions of years ago, Mars was not the barren desert we see today. It had rivers, lakes, even an atmosphere dense enough to support liquid water on its surface. NASA's own data confirms it. Minerals like clays and sulfates, only forming under wet, stable conditions, are scattered across the red planet. Yet here's the shocking part. Mars maintained this stability for hundreds of millions of years before everything collapsed. On Earth, such a planetary balance is maintained by tectonic activity and a magnetic field shielding the atmosphere from solar winds. Mars lost its magnetic field, its tectonic heartbeats stopped, and yet some regions remained strangely intact. Craters that should have eroded, valleys that should have vanished, they didn't. It's as if the planet fought against its own demise, holding on longer than physics should allow. Why does NASA shy away from explaining this? Because the timeline doesn't make sense. According to standard models, Mars's atmosphere should have leaked away gradually. Yet evidence shows rapid, uneven collapse. Water vanished in some regions faster than others. Some polar ice caps survived partially intact. Seasonal frost appears in ways that defy thermal predictions. Something interrupted Mars's natural evolution, and scientists don't know what. The uncomfortable truth: Mars wasn't a dead planet from the start. It was a stable world, and then something changed. something dramatic enough to shut down its magnetic field, strip its atmosphere, and leave behind a desert almost overnight on a geological scale. NASA publishes the data, but never fully addresses the how and why in public channels. The gaps are intentional or unexplained. Either way, the mystery remains. And the most disturbing question of all, if Mars was once so stable, why did it collapse so quickly? What event could turn a thriving, water-rich world into the dusty, silent desert we now see? NASA knows the facts, but they never give us the full story. Mars once had a magnetic field, a shield protecting it from the deadly solar wind. Without it, a planet's atmosphere bleeds away. On Earth, we take our magnetic field for granted. It keeps life thriving. It protects oceans, air, and everything living. But on Mars, the field didn't just die. It flickered, fractured, and vanished unevenly. NASA's orbiters detected these anomalies decades ago. Some regions still retain strong local magnetism, while neighboring regions show nothing. According to planetary physics, this shouldn't happen. A magnetic field either exists or it collapses completely. Mars's patchwork remnants suggest something interrupted the process, something science does not fully explain. Scientists call this crustal magnetism, but it's more than geology. It's a puzzle that challenges everything we know about planetary cores and magnetic decay. How could a core that generates a field collapse in some places, yet leave neighboring areas active? The inconsistencies are stunning, and NASA quietly labels them as anomalies, leaving the public unaware. And here's the twist. The loss of the magnetic field correlates strangely with the disappearance of liquid water. Regions that lost magnetism first show early signs of drying up. Could Mars have died from within, its core shutting down in a domino effect? Or did something external, an astronomical event, a solar surge, or something else entirely, trigger it? Nobody knows the full answer. NASA releases raw measurements, publishes scientific papers, yet the narrative to the public remains. Mars lost its field naturally, but the pattern is irregular. The facts scream irregularity. And it's here, in the core of the planet itself, that Mars' greatest mystery hides. Stand on Mars today, and you'll feel it immediately. A whisper of air, almost nothing. But billions of years ago, Mars had an atmosphere dense enough to allow rivers, lakes, even rainfall. NASA's own measurements, especially from the MAVEN mission, confirm it. Mars lost most of its air to space. The official explanation? Solar wind stripped it away after the magnetic field collapsed. Simple, logical, but there's a problem. The numbers don't add up. Even without a magnetic shield, the rate of atmospheric loss seems too fast, too uneven. Some areas retained pockets of gas far longer than models predict. Carbon dioxide ice caps persisted, subsurface pockets of oxygen remain, and MAVEN readings indicate localized atmospheric spikes. A planet that should have slowly faded instead vanished in bursts, like someone was pulling it apart from the inside. Why did Mars lose its air so quickly, while other regions remained surprisingly dense? Why do seasonal readings reveal transient increases of gases, seemingly defying logic? NASA publishes the raw data, but leaves these questions unanswered for the public. The explanation given, solar wind stripping, covers the facts partially, but the pattern itself screams anomaly. And here's the mind-blowing part. If Earth's magnetic shield failed in the same way, we would not survive long. Mars's strange survival of some atmospheric pockets suggests there might be forces or mechanisms we don't yet understand, quietly shaping its climate long after the core died. NASA detects it, but the silence is deafening. Methane, Detected on Mars, but it breaks down in the thin air within years. Yet NASA's rovers keep seeing seasonal spikes. Something is producing it. Right now, officially, geology. But seasonal patterns, exact timing, and localized bursts don't match natural rock chemistry. NASA confirms the readings, but stays silent on the source. Life, chemistry, something else entirely? Nobody knows, but it's happening every Martian summer. NASA keeps calling it ancient water, but new discoveries tell a different story. Subsurface ice, flowing brines, even possible transient liquid salts. Mars isn't just a dry relic. Water still moves in ways it shouldn't under current cold, thin conditions. Liquid activity today, not millions of years ago, something underground or hidden, keeps Mars alive in secret pockets. NASA publishes data, but never emphasizes the present activity. NASA calls them natural formations, hexagonal cracks, perfect ridges, symmetrical mounds, patterns that geology struggles to explain. Repetition, scale, and geometry are shocking, almost like Mars was carefully designed, not randomly eroded. Scientists observe, measure, and classify, but avoid speculation. Why? Because these borderline anomalies challenge everything we know about natural processes on Mars. Mars and Earth, siblings born from the same solar nursery, same minerals, same early water, similar early climates. Yet today, Earth thrives while Mars is a desert. Why the divergence? NASA's data shows a harsh cosmic truth. Small differences can destroy a planet's habitability. Mars survived solar violence only partially. Some regions preserved life-friendly pockets. Others were annihilated. It's a warning. Earth could face the same fate if we ignore planetary fragility. NASA publishes mountains of raw data, billions of bytes from orbiters and rovers, pictures, chemical scans, atmospheric readings. Everything is visible, yet almost nothing is explained. The more they release, the less the public actually understands. It's a clever strategy, transparency without clarity. Data is there, but the uncomfortable questions remain buried. Odd formations, seasonal methane, magnetic anomalies, all cataloged, all quietly ignored. NASA could tell us the truth, but they don't. Why? Funding, politics, public perception, and the sheer uncertainty of what they see. Every anomaly challenges decades of accepted science. Admitting it publicly could cause panic or controversy. So they speak in cautious language, release data without interpretation, and let the world wonder. Simple answers don't exist. And even if they did, the truth might be too big, too disruptive to share. Mars isn't just a dead planet, it's a lesson in fragility. Its rivers dried, its atmosphere vanished, its magnetic shield collapsed. Every anomaly, every seasonal spike, every briny flow is a reminder. Habitable worlds are delicate, temporary, and vulnerable. Mars shows us what happens when stability fails. Its mysteries aren't just curiosities, they are warnings for Earth and humanity. And NASA studies this silently, knowing the stakes. Magnetic collapse, atmospheric loss, seasonal methane, flowing brines, strange surface structures. Mars doesn't fit a clean story. It's not fully dead, it's not fully alive. It defies explanation. NASA releases the data, analyzes it internally, but never gives a straight answer. The uncomfortable truth: Mars is a planet of contradictions. Its past was stable, its present is mysterious, and its secrets are hidden in plain sight. The questions it raises about planetary survival, about life, about Earth's own future, remain unanswered. Mars is more than a distant desert. It's a warning, a mirror showing what happens when a planet loses its shield, its atmosphere, its stability. Every anomaly we've seen, methane, flowing brines, magnetic remnants, strange formations, tells a story NASA won't fully tell you. And the truth is, Mars may not just be a lesson from the past, it's a glimpse of a possible future for Earth, for us, and the knowledge exists. It's right there in NASA's data. But unless we pay attention, unless we question, we may never understand. If you want real science, real mysteries, and the truth no one else will tell, subscribe now. Only those who truly care about understanding the universe will make it to the next discovery.